going to try to understand a little more about IVP using a practical question. Now we're given an IVP 1 plus x squared divided dx plus 3xy equal to 5 and y of 1 equal to 2 with general solution y is equal to c of 1 plus x squared raised to the power of negative 3 over 2 and plus 5 over 3. So we have to find c and we have to find a particular solution. So this is the nature of an IVP. An IVP, as we saw earlier, is a differential equation given with some initial conditions. Now for this differential equation and initial conditions, they have already gotten the general solution for us. So they just want us to use the IVP and the initial conditions given to find C over here and to find the particular solution, or to write the particular solution. Now you don't have to worry about how we got from this point to this point. I will prepare a video in the future showing you how we got from this particular differential equation to this particular general solution, okay, and eventually we'll obtain the particular solution for this particular case. So solution. Now when you're given this particular differential equation whose solution is already given to us as c of 1 plus x squared raised to the power of minus 3 over 2 plus 5 over 3. Now we are going to apply our initial condition given to us as y of 1 equal to 2. So this becomes y is 2 whenever x is 1. Okay, y of 1 equal to 2. Remember, y is actually a function of x. So the independent variable is what is usually in the bracket, which in this case is x. Then y is the output, which is actually going to be 2. So all we just need to do is anywhere we see y, we are going to replace it with 2. And anywhere we see x, we are going to replace it with 1 squared to the power of minus 3 over 2 plus 5 over 3. So solving, we're going to get 2 minus 5 over 3 is equal to c into 2 raised to the power of minus 3 over 2. So 2 minus 5 over 3 can still be written as 6 over 3 minus 5 over 3 is equal to c into 8 raised to the power of what? Minus 1 over 2. Okay, so how did I get 8 raised to the power of minus 1 over 2? So 2 raised to the power of minus 3 over 2 is still the same thing as 2 raised to the power of 3 to the power of minus 1 over 2, which is 8 raised to the power of negative half. Okay, so we will have 1 over 3 equal to c dot 8 raised to the power of minus 1 over 2. So let's see what this becomes. So what we're going to have from this point is c is equal to 8 raised to the power of 1 over 2 divided by 3, which in other words is square root of 8 divided by 3, and the square root of 8 is square root of 4 times square root of 2 divided by 3, and this is 2 root 2 over 3. So we have found the value of c, right, the arbitrary constant. So this being the value of the arbitrary constant, so the implication is that y is equal to c, which is 2 root 2 over 3. Then we now have 1 plus x squared raised to the power of minus 3 over 2. Then we now have plus 5 over 3. Assuming we decide to multiply all through by 3, what we are going to have is 3y is equal to 2 root 2 into 1 plus x squared to the power of minus 3 over 2 plus 5. So if we go on further, we're going to get 3y minus 5 is equal to 2 root 2 into 1 plus what? X squared raised to the power of minus 3 over 2. I'll take all the variables to the left hand side and leave the constants to the right hand side. So this is going to be 3y minus 5 all over 1 plus x squared raised to the power of minus 3 over 2 is equal to 2 root 2. So this is a good way to leave your answer. If you don't know how to leave your answer, you can take all the variables to the left hand side and leave the constants on the right hand side. So if you simplify this further, what you're going to get is 3y minus 5, then 1 plus x squared raised to the power of 3 over 2 is equal to 2 root 2. And the simple of indices that I applied here is 1 over a raised to the power of minus n is a raised to the power of n. So this term in the denominator over here, when it comes to the numerator over here, you can see that the sign of the power changes from minus to plus. So this is what we know as our particular solution. So this is the particular solution, okay, for that equation. So you're going to understand the techniques of differential equations. You understand more problems pertaining to initial value problems, and learning how to go from a given differential equation to the general solution. Then if there is any initial condition, you will also learn how to use that initial condition to find some arbitrary constants that will now enable us to find our particular solution. So just before you go, take note of the following. A general solution is an expression of y whereby there is at least one arbitrary constant. Is that okay? Then a particular solution is a solution whereby through some initial conditions we are able to obtain the value of the arbitrary constant and express the solution in terms of the respective variables. No more arbitrary constants again. So this is just a summary of what you're going to be encountering as you go further in learning about initial value problems and methods, analytical methods of solving differential equations. So once again, thank you for watching. You can stay tuned, like, subscribe, and share to your friends. Hit the notification bell so that you can be updated on future videos.